Have you ever looked at the perfect spiral in a sunflower? The intricate design of a snowflake? Or the breathtaking swirl of distant galaxies? And felt like you were seeing something mathematical? It's like these patterns are whispering the universe's secret code. We use math for everything. From predicting where a baseball will land, to charting how planets dance through space, even to understanding that buzz from your phone. But here's a truly wild idea. What if math isn't just a tool we use to describe reality? What if reality itself, everything you see, everything you touch, and even everything you are, isn't just explained by math, but actually is math? This mind-bending idea is called the mathematical universe hypothesis, or MUH for short. Cosmologist Max Tegmark is one of its biggest champions, and the core idea is seriously radical. It suggests that our physical reality, the world around us, isn't just described by mathematical structures, but it, itself, is a mathematical structure. Take a moment to let that really sink in. This isn't about math being a useful language we invented to understand nature, as Galileo famously thought. Nope. This hypothesis proposes that nature itself, the entire cosmic playbook, and everything within it, yes, including you and me, is literally made of pure mathematics. And if that's true, the implications are staggering. It forces us to completely rethink what existence means, and our place in the grand, cosmic picture. So, why would brilliant scientists even consider such an out-there idea? A huge reason is something Nobel Prize winner Eugene Wigner famously called the unreasonable effectiveness of mathematics. It's this weirdly consistent phenomenon, where incredibly abstract mathematical concepts, sometimes created with absolutely no practical use in mind, turn out to be precisely what we need to unlock the secrets of the universe. For example, math told us the planet Neptune should exist, long before any telescope actually found it. The same goes for radio waves, and even the Higgs boson particle. And when you look at the fundamental laws of physics, like gravity, or the bizarre rules of quantum mechanics, what are they, at their heart? They're beautiful, elegant, mathematical equations. It's almost as if the universe wants to speak in the language of math. Or, if the MUH supporters are right, it's because the universe, fundamentally, is math. But the mathematical universe hypothesis doesn't stop there. Oh no, it pushes the boundaries even further. It suggests that any mathematical structure that is logically consistent and holds together on its own actually exists, physically. Think about that. Our universe, with its specific collection of particles and forces, is just one particular mathematical structure among countless others. This naturally leads to something called a level 4 multiverse. Imagine a truly mind-boggling collection of other universes, where each one is built on a completely different mathematical foundation. That means they could follow entirely different laws of physics, or be governed by math that's utterly alien to us. And here's the really wild part. If any of these mathematical universes are complex enough to support self-aware beings, those beings would perceive their world as completely real, just like we do. This is a modern twist on an old philosophical idea called Platonism, the belief that mathematical forms aren't just abstract ideas, but the literal building blocks of every possible reality. As you can imagine, this is where things get really complicated, and, let's be honest, pretty controversial. The MUH has its fair share of critics, and they raise some very tough questions. For starters, some critics point to Gödel's incompleteness theorems. In simple terms, these theorems say that in any math system complex enough, there will always be true statements that can't be proven using that system's own rules. So, if our universe is one of these mathematical systems, does that mean parts of reality are fundamentally unknowable? Or, does it mean the MUH has a major flaw? Tegmark has responses. He suggests that maybe our universe is a special type of mathematical structure, one that is fully knowable. Or perhaps the math needed to describe it is computable, meaning we can, in principle, figure it all out. Then there's the massive challenge of testability. I mean, how do you scientifically verify a hypothesis that claims there are countless other universes out there, each based on entirely different math? It's a very fair question. Tegmark argues that if the MUH is correct, we should continue to discover more and more mathematical patterns in the laws of physics. He also believes that if our universe is a typical mathematical structure, we could eventually figure out how common its features are, compared to other mathematically possible worlds. And of course, there's the whole philosophical hornet's nest. Is math something we discover, as if it's already woven into the fabric of reality? Or is it something we invent, just a brilliant human language for describing what we see? Because if reality truly is math, then what about our inner experiences? Think about consciousness, or what philosophers call qualia. That raw, subjective feeling of seeing the color red, or tasting a strawberry. Can we really reduce those rich experiences to just numbers and equations? Some philosophers argue that things like the flow of time, or feeling joy and sorrow, seem to require something more than just a fixed, unchanging mathematical description. There you have it. The mathematical universe hypothesis is, without a doubt, one of the boldest and most mind-expanding ideas, where cutting-edge physics meets deep philosophy. It offers a surprisingly elegant, though definitely startling, framework for understanding why mathematics and the reality we observe are so profoundly intertwined. It even hints that the ultimate answer to the age-old question, what is reality, could simply be numbers. Now, it's a very long way from being proven. There are serious criticisms about whether it can even be scientifically tested, and plenty of philosophical puzzles to solve. But the MUH undeniably stretches our minds and compels us to think. It forces us to confront a truly wild possibility that existence itself is one colossal, magnificent mathematical tapestry, and we are all just intricate patterns woven directly into its fabric. What's your take on all this? Do you think our reality, at its deepest level, is all about math? Are we like characters living inside some vast cosmic equation? We'd love to hear your thoughts and ideas in the comments below. And hey, if you enjoyed this journey into the weird and wonderful nature of what's real, do me a solid. Hit that like button, subscribe for more adventures into the cosmos, and make sure to ring that notification bell so you won't miss what we explore next. Thanks for watching. See you next time.